In this section we are going to talk about marginals. Marginals use our derivatives to give us some information about some of the application type problems we're going to be looking at. In short, a marginal of a function tells us the approximate value of one additional unit. Okay, that doesn't say a lot, so let's look, for example, at cost. Let's say I have a cost function where the cost is given in dollars and x is the number of units. Then c prime, meaning our derivative of the cost, which we're going to call the marginal cost, is the cost in dollars to produce one additional unit of the product. Okay? And here again, I want to point out c prime of x is the same as what we saw in the last section, dc dx, which means it's the rate the cost is changing with respect to the number of units. Okay? This is a particular type of derivative. Okay? There are three types of marginals that we're going to look at. So if Q is the number of units, then our marginal cost, which we can denote a couple of different ways. One is MC for marginal cost, or C prime of Q, so the derivative of our cost with respect to the number of units, or dc dq. Okay. All of those represent our marginal cost. Our marginal revenue, same thing, there's three different ways we can write that. MR for marginal revenue. It's the derivative of revenue with respect to the number of units, so R prime of Q. Or, as I just said, the derivative of revenue, so dr dq with respect to the number of units. Okay. And lastly, for marginal profit, again, same idea. Now again, notice here I say if Q is the number of units. If I change my variables here will change as well. And one of the things you will get used to as you go through the different sections of the text and some of the problems that we will deal with is that Q is not always going to be your variable for the number of units. In some cases you may have X. So you have to be aware of that. But again, for each of these, the thing to remember is it's a change in cost, or change in revenue, or change in profit with respect to the number of units. That's what we mean by a marginal cost, or a marginal revenue, or a marginal profit. Let's look at an example. So let's take our cost function, for example. So we kind of talked a little bit about it there, and we just want to look at some different aspects of our cost function. And in this case, I'm going to throw in here, let's also assume that we've got 10 units. So in this example, given our cost function, C equals 0.1 Q squared plus 3, we want to first find the average cost. And we want to find the average cost when there are 10 units. Then we want to look at the marginal cost and figure out the marginal cost when there's 10 units. And we want to compare those numbers and just see what's going on there. So, for average cost, if you remember before, average cost, this is from your prerequisite course, C bar, we denote average cost to be our cost divided by the number of units. Okay? So in this case, if I want the average cost for this function, that's going to look like 0.1 Q plus a 3 over Q. Okay? And if we look at our average cost at 10 units, we can see this is going to be 0.1 times 10 plus 3 over 10, which is going to look like 1.3. Okay? Now we'll talk about what that means in just a second. Right now it's just a value that we've gotten. Let's look at our marginal cost equation. Okay, so our marginal cost we know is going to be C prime of Q. Okay, so using our basic properties from the last time, C prime of Q says that it's going to be 0.2 Q, and again derivative of 3 is just 0, so there's our marginal cost function. Okay. If we look at the marginal cost when there's 10 units, we can see we're going to get a 2. Okay, so what do these things mean? Let's think back. Average cost tells us the cost divided by the number of units. In other words, it's the cost per unit. So this is telling me that this is when there are 10 units, the cost is $1.30 per unit. Okay. The marginal cost, as we've said, tells us the cost for an additional unit. So this says that when there are 10 units, the cost to produce the 11th unit is $2. Okay. So even though well, functions look very different, these do mean different things. And the same thing can be said for revenue. Okay. So for our revenue function, let's take this one for example. Again, the marginal revenue will work very similar to the marginal cost. The difference is if I go the other direction. So when we talked about average cost and divide it out from our cost equation, we don't get quite the same thing when we look at our revenue. There's no average revenue. So here, if I'm looking at my revenue equation, 250Q plus 45Q squared minus Q cubed, if I start out the same way and I think of going down instead of looking at marginals, taking derivatives, if I divide out, remember here, if I take and divide out by Q, this gives me my little p, which is my demand function. Okay. So demand or price, if you want to think of it as price, this would be able to tell me my price per unit. Okay. So in this case, if I took R divided by Q, we would get 250 plus 45Q minus Q squared. And this would give me my price function for this particular revenue equation. Okay. And again, let's say we do this at 10 units. So just like the last one, let's plug in at 10. Okay. So my P of 10 is going to look like 250 plus 450 minus 100, which looks like 600. Okay. And we'll talk again about what that means in just a second. If I go the other direction and I look at my marginal, so R prime of Q, this one actually means to take my derivative. So again, I can use my basic properties. My derivative here is going to look like 250 plus 90Q minus 3Q squared. Okay. From there, plugging in my value, okay, we'll get 250 plus 900 minus 300, so it looks like 850. Okay. Again, what do these things mean? Well, if I'm looking at this first one, like we said, if we divide out by the quantity, this gives us our price per unit. So this is telling us our price is $600 per unit. And this tells us the revenue on the 11th unit is $850. Okay. Let's look at one last example, and that is, let's say I gave you a cost function and a revenue function, and we want to find the marginal profit. Okay. This is one of the examples that takes us back to our basic properties where we're adding and subtracting derivatives. Okay. So here, if you remember, profit is equal to your revenue minus your cost. So our marginal profit is our marginal revenue minus our marginal cost. Okay. Another way you could do this is actually find the profit function and then just take the derivative. But we can also do it this way. So our marginal profit in this case, well, our marginal revenue, we take the derivative using our power rules here and our coefficient rules. Looks like a 3x squared minus a 4x plus 5. Again, the 7 will go to 0. And then for our marginal cost, looks like a 6x plus 0. So now combining those derivatives says that our marginal cost is going to look like 3x squared minus 10x plus 5. There's our marginal profit.